Good afternoon, everyone, and welcome back to our Research and Winemaking webinar series. Thanks for being with us today. We hope you will enjoy it and you will learn skills and develop knowledge to be used in your vineyard and winery. So I'm Dr. Aude Watrelot. I'm an assistant professor and extension specialist in the Department of Food Science and Human Nutrition at Iowa State University. And I'm co-hosting this webinar with my friend and colleague, Drew Horton, who is a research specialist of enology or research enology specialist at the University of Minnesota's Grape Breeding and Enology Project. So before starting the webinar, I just wanted to provide you some instructions. So the webinar is being recorded and the recording is going to be available on YouTube by the end of the week. Also, if you have any questions during the presentations, feel free to use the chat box that you should be being able to see if you click on the three dots at the bottom of your screen. And so we will answer your questions by the end of all the presentation. Also, at the end of the webinar, you're going to receive a link for a survey to complete, and that's really helpful for us to know how we can improve for future webinars. So please take few minutes to complete the survey at the end. So today we're going to have quite a lot of three presentations. The first one is going to be from Chris Gerling at Cornell University. He's going to discuss winery sustainability. And then with Sara Martin from Critical Path Engineering Solutions, PLLC, who will present wastewater and water use reduction in the winery for a total of about 40 to 45 minutes. After that, I will present some insights about the reuse of grape pomace in the winery to produce a value-added product, which is called piquette, for about 10 minutes. After the three presentations, we will discuss and answer any of your questions with a panel, a group of winemakers and grape growers from Minnesota and Iowa. So Scott Ellenbecker from Round Lake Vineyard in Minnesota, Jonita Boyer from Tassel Ridge Winery in Iowa, and Ken Foulker from Cedar Ridge Distillery in Iowa. But let's start by the presentation of Chris and Sara, and I will make you presenter in a few seconds.
And I will introduce Chris. My pleasure to introduce Chris Gerling. Chris is a senior extension associate in the Department of Food Science at Cornell Agritech in Geneva, New York. He works with the craft beverage industry to create educational programs that support the growth and improved quality of premium wines, ciders, and distilled spirits. He's also the manager of the Vinification and Brewing Technology Lab, where fermentations are conducted for research projects and applied trials, and the Cornell Craft Beverage Analysis Lab, where products can be submitted for troubleshooting, routine analysis, or sensory appraisal. Chris is a busy guy. He also organizes and conducts workshops and seminars that focus on production and analytical techniques for farm-based beverages. Chris is a past chair of the American Society of Enology and Viticulture Eastern Section and serves on the ASEV National Chapter's Laboratory Proficiency Committee. He is also a member of the Cider Institute of North America's Executive Committee. Chris, the floor is yours.
Thanks. Thank you, Drew, for that. Can everybody see and hear me? Are we back? All right, good. Excellent. Thanks, everyone. Happy to be with you today. Looking forward to talking to you about some fun things. I think there's opportunities here and ideas, and that's what we're just trying to give you today, are some tools and some things to think about for how you're going to operate your own winery. And all these things are scalable, we hope, and applicable in different ways, shapes, or forms. Nothing is completely cookie cutter. You can adapt and adopt as you see fit. So this is a project that we're going to be presenting mostly that was a team effort with our friends from the Rochester Institute of Technology's Pollution Prevention Institute. So that's Ken Schlafer and Gene Park, who are a big part of this project. And then Sarah, who you'll be hearing from shortly. And then there's me. And so it's a good team. So what we did was we did what's called an ERP, an Environmental Results Program. It's a sustainability initiative, and we were working with New York State wineries. But as I said, there's nothing that limits this to New York State wine. It's just where we were and who we were working with for this trial. It's obviously can be used in any climate, in any condition, in any size winery, we hope. So it's not something that you should feel is restricted to that area. It's just, as I said, where we did the work. And so the end product is this workbook, as you can see. Here's a hard copy version of it. And it's supposed to provide key best management practices that can help you with lowering your costs, reducing environmental impacts, saving resources, and demonstrating your responsibility. And so it's supposed to be a tool that you can use to help both for everything from production to marketing. And we have these hard copy versions, as I showed, but you can also go to the website and you can download these documents. We're going to talk about 2 documents today. One is the workbook, and one is primarily Sara developed, and these are available on our websites. And I'm sure that we can send Aude and Drew the actual sites if you don't get those sites today. If you can't find it through Googling, we can make sure you get the direct links so you can download these documents, and you are welcome to download these documents. We hope you'll download these documents and use them. So please do. So one of the things we're talking about today is water use and reducing water use. And one of the big messages that I think I'm going to send in the minutes that I have to talk to you is that measurement is where we start, right? You can't manage what you can't measure. And that's, business 101 or whatever. It's the old doctrine, but it's true. And there's a lot of small wineries who are out in rural areas who are on wells. And if you have a good well, then you don't worry about water because you don't have to pay for it. And if you have enough, then maybe you don't know. And so there's plenty of wineries that I work with that just don't know what they're using. They don't have flow meters in place. And so the very first thing you can do is place a flow meter, and then you can tell how much water you're using. And if you're on a municipal water system, if you're in a city or whatever, then you're probably getting a water bill, and that does give you a gross number for how much water you're using. But the more you can dial down, the more you can sub-meter, the more you can put meters in specific places or for specific purposes, and you can monitor that over time, the more you can know about, the more granular your data can be about how much water you're using. And then obviously that's the first step towards reduction. Now you can reduce water use without knowing how much you're using. There are definitely techniques, but wouldn't it be great to say, we started here and now we're here, we're working towards here. So it's, and very few places have sub-metering, and I understand it's not a priority in a lot of places, but it's something that is relatively inexpensive, relatively easy to do. And once you start with this kind of measurement, you can get a lot of information relatively easily. Same thing for energy, right? Everyone gets an energy bill, everyone gets an electricity bill generally, but and most people we know where the hogs are. We know that it's the compressor for the chiller. We know that it's the bottling line. There's certain uses that where we know we're using a lot of energy kind of intuitively, but have you ever really stopped to think about how much am I using, in this job for this task for this amount of time? And as you can see with our surveying, nobody is doing real sub-metering with electricity. And it's something that, once again, that information could help you to figure that out. I'm not sure how it works where you are, but where we are, we have what we call demand charges for your utility bill. And basically, for most commercial organizations, if you're a commercial operation, they basically take your peak demand and call that and start to bill you based on that usage. And so knowing what those peaks are and when those peaks are and what you can do about those peaks can have a dramatic effect on your electricity bill, even if it's relatively rare that you are doing these things. That still may be how your utility has made your bill. So those are things to be aware of. Once you get to knowing what you're doing and knowing what you're using, there are some very basic things you can do, including insulation and basic kind of things where it's passive, it's inexpensive, and you're saving the energy that you're using. And so there is in our workbook that shows more specific things about this, but just insulating the the cold can help you to save significant amounts of energy. Maintenance is another key area. This is not like, we're not talking about having some kind of hydrogen fuel cell system you need to have, right, to be more sustainable. You don't have to invest lots of money in some kind of advanced system. Installation and maintenance, just making sure that you're keeping everything, you're keeping your chillers and cooling systems are free of obstruction, making sure you're routinely vacuuming things out so that there's not dust accumulation, getting the dust off of there. It's fairly, this is not to use too much of a wine pun, but low-hanging fruit, right? So these are easy things that you can do. Everybody can do them. It doesn't require investment. Major investment doesn't require, advanced systems or anything like that. And so if you're doing these things, I know everybody's busy. And as we were talking, as we were getting introduced to our panel, most of you wear way more than one hat, right? At your business, and you have lots to do. So these things can easily slip your mind. But if you can do these things, it's not, it doesn't have to be that complex thing. Compressed air, similar situation, maintain the compressor. Compressors are not efficient. And so not using them whenever available is the best idea. But if you can make sure that they're well maintained, that's the next best thing. LED lighting, right? Most everybody's done that now. That's not really, it's kind of old news, but it's still something that can dramatically lower your energy bills. Making sure you use timers if possible, motion detectors. Once again, I know that most wineries in my area and in yours are probably not. It's not like you have a third shift and 50 people in the space or anything like that. When you're there, you turn on a light. When you're gone, you turn it off. But just things to think about. Programmable HVAC thermostats. Once again, easy things to do that are not necessarily requiring thousands of dollars of investment over years or anything like that. Renewables are great. If you have access to them, there's usually pretty good incentives from lots of different places. The states do them, the utilities do them. And so if you can put in solar or wind are really good. Geothermal can sometimes be a little less suited to the winery environment. Some people use it, but it's definitely an option that you can consider. Now, actual winemaking processes, some things that we recommend in our workbook, something that Aude and I have talked about a lot and we've done some trials with, is instead of having to pay for utilities, use cold for cold stabilization. Have you looked at possibly some tartrate precipitation inhibitors and things like Zenith you may have heard of? And so those can provide an option. A lot of places where maybe wineries who are listening today are located, you can use the outside to do some free cold stabilization. People do that in our parts, in our neck of the woods. Sometimes it's not as you don't get the conditions you need at the time you need them, but it is an option. But also using these products can be a choice that can do it. Nobody using electrodialysis in this part of the country because those systems are very expensive, are very large scale. So that we weren't surprised that nobody said yes to that. But these inhibitors, Zenith and its family of products, are something that are becoming more widespread, pretty easy to use, and can be quite effective depending on, there's some wines that are less effective, but on many wines, they can be a good choice. We know the kind of all the hallmarks. There's nothing surprising here. Recycling where possible is something that we recommend, obviously, with glass and with cardboard. It's a big debate right now in our region about what is actually happening to things that are being left to recycle. And we are also looking at, our state has been toying with extended producer responsibility laws, where if you sell a container, you are responsible for how that container travels down the supply chain and through the waste stream. And so that's got people's attention. And so we are starting to look at potentially, there's pilot programs being investigated, at least for bottle reuse, things like that. And so what happens to bottles, the glass bottles, is something that people are thinking more and more about. And obviously the first step is to make sure that they're being recycled to the best of your ability. We're going to talk more about this later, but when you have your pumice, when you have tartrates, when you have sludge, when you have stems and seeds, all these different things, what are you doing with it? The best thing, obviously, well, I mean, the worst thing, let's start with the worst thing, is to actually throw it in like a trash or a landfill, right? But then the next thing that most people are doing is just composting them, spreading on the land, and that's not a bad use, depending on your situation and your layout. But ideally, you could even turn this into a product, right? Can you do something lucrative with it? There's possibilities out there, right? And we're going to talk about some of the uses in this webinar, but there's other things you can do to maybe get some value for these products, because there is no waste, right? Anything that you can separate, that you can concentrate, that you can isolate, then there's a value there. Probably every compound, every substance has a use somewhere in the world for something. And so, yeah, we'll talk more about that. But we're talking today specifically about water. We're going to talk a lot more about wastewater. One of the things we talk about with wastewater reduction is if you can reduce your water use, then you can reduce the size of your wastewater system. And so that's always optimal, because then your system is smaller, it's less expensive, less maintenance, everything. So if you have less waste going to that system, that's always the first place to start. And so how can we do that? We can not just use the hose all the time as our first option. We can use dry methods. We can use sweeping. We can use collecting solids to the best of our ability before we go in there with a hose, before we go in there with a CIP system. We can use timers, flow restrictors, low flow, high pressure hose nozzles can reduce your water usage. Using a high pressure cleaning system, or a system, besides just spraying a hose in the barrel, can you make some kind of a system that's going to give you a more efficient cleaning method? And wherever we can increase pressure and or temperature, then usually we can be more effective with less water. Chemical use, making sure that we're being prudent with our detergents, with our sanitizers. One of the things that we'd love to recommend for people is, can you come up with ways, if you have a tank where you're doing a final rinse, and basically you've already put all the chemicals in there, everything is, you've already gotten all the solids out, everything like that, and now you're just doing a final rinse, maybe you're rinsing out a detergent or a sanitizer, and there's really nothing, and that water is almost pristine. Can that be your first rinse in a dirty tank, right? And it takes a little bit of infrastructure sometimes, a little bit thinking about or planning to do that, and you need to have 2 tanks that are dirty at the same time and all that jazz. But if you can do that, what a great use for the water. Using predetermined amounts of water versus just using kind of as much as it takes, which is what most of us say, me included. I know I've worked in a winery, which is, what has to happen. Using test strips to measure our concentrations. Why does that, how is that a sustainability thing? Well, maybe you bought like a big drum of some detergent and you keep it around for a year plus, and you're thinking, oh, maybe it's starting to go bad. Should I just throw that out? Well, what if you had a test strip so you can measure the concentration? And now you can figure out, okay, well, I need to add 10% or 15% more to get to the same concentration that I was at before, but I can do that. And now I don't have to throw out the tub, right? I can keep that longer. So things like that. Rotating chemicals. We often in the wine industry kind of get our go-to, and we just use the same one over and over and over again. And we just know that every compound, no matter how great, has every cleaning detergent and every cleaning product has strengths and weaknesses. And inevitably, you will be either causing a little bit of corrosion maybe on some surface or some lining or on some gasket or something like that, or not. There's some population out there. There's some spoilage bug that's just a little more resistant to that than all the other ones, and is, over the time is not getting knocked down to the same amount. And so every once in a while we need to throw a curveball and try a acid-based detergent instead, if we're always using a basic one, an alkaline one, just to keep things fresh. It'll make everything more effective. It will battle resistance and things like that. written protocols for these things. That's required. If you get audited by any kind of agency, they're going to want to see your protocols for these things. So you need to do that. And you can see that not everybody did on our survey. All right. Cross-flow filtration is a great option. They're getting smaller and cheaper every year. And so hopefully they will eventually find their way out to every small winery, because they're just a great way to go. They use, as you can see on the pros and cons chart, they are efficient. They're self-cleaning often. They use less water. They generate less waste. And so it's a great option to consider. All right. I think that it is time to hand off to Sara. Whoops.
Thank you, Chris.
Yeah.
Let me change the role. And let me introduce you, Sara. So Sara Martin is a licensed professional engineer with over 20 years of experience in project development, management, and design of various municipal and industrial water, wastewater, and utilities projects. Her experience also includes design, build, implementation, startup, operation, and troubleshooting of anaerobic and aerobic wastewater treatment systems. Before starting Critical Path Engineering Solutions, Sara worked previously at O'Brien and Gear Engineers, now Ramboll, for most of her career, one of the leading consulting firms in these services. Sara Martin has a diverse experience background with the ability to take a project from initial concept through design and implementation, including bench scale treatability, pilot studies, and project scale-up. Her diverse experience also includes subject matter expertise, specializing in complete lifecycle project review and guidance of wastewater process treatment design, construction, and startup activities. Over the years, Sara has developed working relationships with various experts, technology providers, and consulting professionals in water and wastewater treatment design. Sara, I think you're ready to go.
All right. Thank you. Can you hear me?
Yep, perfect.
All right, good. All right. So Chris did a really good job at talking about, some of the sustainability up front. I am going to talk a little bit about, what you do. You do the best you can to get some of the waste and wastewater, keep it out of the drain, but I'm going to kind of cover what happens when it does make it in the drain and how to manage it. But before we do, I just kind of want to review typical wastewater sources, because it kind of helps to always go and understand where wastewater is collected in your facility, and that kind of helps you focus on what areas you need to kind of, because each area will kind of contribute different pollutants to the drain, and if you have to treat it, it's best to understand where it all is coming from and what's in the individual streams. So typical production or industrial process wastewater, from the crush, we got the pomace and the juice, and this usually, the juice is very high in sugar, and what that is, that equates to high organic content in your wastewater, and typically a lot of solids can come down the drain from this process as well. Next, other water users are vessel and equipment cleaning operations. Typically, if you get done with a batch, you have to clean out tanks, and when you first start out, there'll be a lot of product still left over in the tank or tank bottoms. And these all carry high organic content and solids that are pollutants in wastewater that we'll talk about how to treat later on. And then there's just, there's environmental cleaning, keeping everything sanitary, floors, walls, etc. There's spillage that happens. We try to avoid this, but sometimes we do have spillage. And then there's also wastewater is produced from utilities, such as boilers, chillers, cooling towers, air compressors. The ones you don't think about, which as wineries grow more into places for people to come do festivals, and people like to get out and have glasses of wine, it's kind of become more of a social event. what a lot of wineries that we're finding are struggling more with the people waste or the restaurant waste. You know, especially if they have large events where they can go from using, you know, say 3,000 gallons a day to 6,000 gallons a day. You know, so we'll talk about that a little bit later, but then there also are restaurants. Restaurants typically can have a lot of oil and grease, food solids, and higher strength waste associated with food production. So these are ones you don't think about until you start growing and getting more and more people coming, which is a good thing, but also it can be a tough thing in the wastewater area. So waste to minimize. So we talked about wastewater having different components. Typically you want to keep as much high strength waste out of that. High strength waste we define as the actual wine itself or the pomace or any sort of food or organic material we tend to say is a higher strength waste. To put it in perspective, a juice is typically, could be 100 to 200,000 BOD. We use that as a measurement of organic strength in wastewater, whereas human stuff is typically 200 to 300. So you can just kind of get the order of magnitude of a glass of wine in organic strength versus what we typically produce at our households. So getting that high strength waste out of the sewer will help a lot towards decreasing the amount of wastewater treatment you need, which requires energy and chemicals, as well as overall size of treatment. And what can you do with this waste that's sustainable? Well, you can haul it. A lot of people are hauling it to anaerobic digesters now, where you can take this waste and create renewable energy. We were talking about the pomace or some of the solid material can be composted. And there's plenty of studies going on about environmental ways to dispose of your higher strength waste. One thing I do recommend strongly is segregation of sanitary and process. We talked about the human stuff. These typically will have two different types of treatment. So it's best you can find more sustainable ways to treat each if they're separately, but once they're together and you have the human side in it and there's pathogens, then you have a lot less limited areas you can take your process or segregated waste to. Another thing to consider is spill containment. We talked about the high strength waste and solids causing problems downstream in treatment. So always, and chemicals too, chemical spills can upset treatment processes downstream. So always make sure everything's contained properly. Chris talked about recycling rinses, using your last rinse as your first rinse. High pressure nozzles, chemical usage minimization, we talked about. And then, operators always love hoses in any industry. It's very common, but, can you sweep up your materials and put it in a for instance, if you have a bunch of stuff spilling on the floor, can you sweep it up and put it, segregate it to where you can take it to a more sustainable disposal method than just hosing it with water down the drain, where you create wastewater that, again, wastewater takes energy and chemical to treat. Interceptors for solids, this is very highly recommended, especially if you have a restaurant. This is basically just a wide spot in the pipe for solids to drop out, where they can be pumped out later and taken to a more sustainable area for treatment or disposal. Grease traps if you have a restaurant. Oil water separators, keep the grease out of the sewers. And then sometimes what people do is, if you're going to have surges of people for larger events, they'll just bring in portable bathrooms for those larger events. That way you don't have to deal with the large volume that comes with having festivals or large events at your wineries. So wastewater management was one that we talked about as part of our, and a lot of wineries during the study that we did, as you can see by the numbers, didn't really have any treatment to manage their wastewater. A lot of wineries are still on septic systems that are getting antiquated, especially as they grow and more people are coming and more visitors. they're taxing these existing subsurface treatment systems. And then when they, one common question is they don't know where, okay, if I do want to treat it, how do I do that and where do I go? So we part of where Chris led you to, we've kind of come up with the guidelines for managing winery wastewater. And I'll kind of go over the highlights of it for here, but this is available on that same webpage that Chris had referred to. But really, at the end of the day, once you have wastewater, there's only a few places it can go. I mean, it doesn't just disappear. You could evaporate it, but it's very expensive, so you don't. But typically, most discharge to subsurface, again, especially if they're a smaller winery, they may have started off fine on a smaller septic system. As they grow, though, and they have to find somewhere for this water to go, once it's treated, you look to, depending on your location, you could either do direct discharge, which is discharge to the environment, and that's through an intermittent stream or a small body of water where you have to treat it to the quality of that water body before discharging it. This is typically pretty expensive treatment. So the next layer down is looking for if you're near a sewer or some sort of municipal treatment plant. If you're not near one, you may consider hauling depending on the volume of your wastewater, just because, again, there's no economy to scale at wastewater treatment for some of the smaller to medium-sized wineries. And then there is, in some areas, you can do land application, and this is where the segregation of human waste comes in and chemicals. You really, most places won't allow you to do land application, nor would you want to if there's human waste or chemicals present. And depending on the level of treatment or segregation of the cleaner waters, is there reuse or irrigation use for your wastewater? And all of these are typically regulated, or there's guidelines for doing all of these different disposal methods for wastewater. And then you kind of got to start thinking, is there a sewer? I think we discussed, is there a sewer available or a municipality nearby? I guess, what I found in most is that typically for a small to medium-sized winery, less than 10,000 gallons a day, 5,000 gallons a day, you typically would want to maybe even haul, get a collection tank and haul. It can be cost prohibitive to treat, the smaller volumes of water. But if you do not have a sewer available or there's no, then you consider segregating the sanitary waste at least, and trying to do maybe just a septic system on that, and then treating your process wastewater separately. That just allows you more options and disposal methods for the process wastewater versus the sanitary. And if you have an existing septic system, it allows you not to overload it with the higher strength waste you get from as we talked about, the juices and the wine itself all have high organic content that can overload septic systems. They're really not designed for much more than human waste at the end of the day. If you are seasonal, you might consider temporary facilities, or again, we talked about hauling for peak season, depending on your seasonality of your winery. This may be a good option, not to have to build a huge treatment plant that's only utilized, 25% of the time. We talked about the importance of segregation, and then, do this cost to benefit analysis of treatment versus trying to find a local wastewater treatment plant. And, basically, does the volume generated and the cost justify having to not only build yourself a treatment plant with a typical capital of $50,000 up to $500,000, depending on size, plus all the operation costs. It's not like you just push a button and the wastewater treats itself. You have to have operators operate all this equipment. So if you're a smaller winery and you, say have 4 or 5 employees, you might have to add at least another 1 to 2 just to operate your wastewater treatment plant. So again, it's a big problem statement as wineries grow, especially in our area, in the Finger Lakes area. You know, just because these are considerations they haven't had to think about before, where they're using septic systems that that's the wastewater for essential. They haven't had to think about it for a long time. So if you're going to do wastewater treatment plant and or make decisions of where it goes, you really need to do a proper basis of design to make these decisions. And that is to understand your seasonality. And this is where Chris was talking about metering. Understand, like, okay, you know, maybe 2 months a year you have 20,000 gallons a day and the rest of the months you have 5. That's a different problem statement than if you had 20,000 gallons a day every day, or, you know, every day throughout the year. Understand if you're going to do restaurant or hospitality there, because again, this makes some variable wastewater as well. And what kind of restaurant and hospitality you're going to do there. That also makes a big difference. If you're just going to do, like, you know, wine tasting and just some light fare, that's probably not a big deal. But if you're serving meals and you have a full-on restaurant, that can create quite a bit of wastewater in itself. Or if you're ever planning to. Understand quantity variability. You know, crushing season, you know, might be 2 months a year, so that might create a more high strength wastewater than other months of the year. So you may just think about hauling for 2 months a year, and then the rest of it is a lower strength wastewater, depending on your operations. And then spills, we talked about, you have to understand chemicals. And the reason I say that is a lot of times for the organic content, you have to have microbiology to treat the wastewater. Even septic systems use microbiology to treat the wastewater. And the reality is some of the chemicals that we use to kill the bugs up in the winery and to protect us and food safety can kill those bugs and render the treatment useless. So understanding, you should always minimize your chemicals just from a cost and a sustainability perspective, but you should also minimize them from an impact to downstream wastewater treatment, especially if you're using microbiology. Always understand your expansion plans. I get sometimes you don't know what's coming, but if you know you're going to build out, think of some of these things that we mentioned above so that you build them into your plan. And you know, if you're going to build a wastewater treatment plant or have to do wastewater treatment, do it once and do it right so that, you know, you don't have to keep adding on, because that's when I see people really mess things up. You really should have future planning in that. And then solids is the easiest thing to get out. So like I said, settle it, filter it, whatever you got to do, but solids are the easiest thing to get out of wastewater, and they can make quite a big impact to the overall strength of the wastewater. It's the easy low-hanging fruit, as Chris said, to lowering the strength of your wastewater for treatment or hauling, depending on where it's going. And then always think about staffing, because again, I told you these systems don't run themselves. So you got to understand, if you're going to have to do treatment, you're going to have to actually operate it. And odors and aesthetics are a big one too. If you have people come into your winery, last thing you want is for them to smell a wastewater treatment plant, especially with the human waste, can make them quite undesirable. There's a lot of vendor solutions out there. You know, maybe I'm biased here, but I always engage engineering just to help. At least if you're going to go to a vendor-driven solution, have an engineer oversee it so they can ask all the right questions. Make sure you have the right controls, aesthetics, and that they're giving you quality equipment and instrumentation. Always work with your municipality. I told you the different ways to discharge, but always work with them upfront to understand what the rules of engagement are for yourself. It's hard to plan anything without knowing that. And sometimes you might find a good outlet just by talking to a state agency or municipality. They might have a solution for you that isn't you building a treatment plant. Engage engineering early. Again, sometimes we think of things that you may not. And then make sure you do some sampling and capture the variability of your wastewater. I've seen people take one sample in design and they either end up with a completely oversized plant or a completely undersized wastewater treatment plant. And they spent all that capital basically for nothing. So just things to think about. And that is all I have.
All right. Well, thank you, Sarah, and again, thank you, Chris, for your very informative presentations. There's a lot to think about. If any of their attendees, if any of our audience have any questions, please type them in the chat box, and we will answer them after the presentation from Dr. Aude Watrelot. And for those who don't know her, I want to introduce Dr. Aude Watrelot. She's an assistant professor and extension specialist of enology in the Department of Food Science and Human Nutrition at Iowa State University. Dr. Watrelot's research area is fruit, grape and wine tannin, and polysaccharide chemistry, and their relationship with wine quality. Dr. Watrelot graduated with a PhD degree in food science from the French National Institute for Agricultural Research, that's the INRA, and the University of Avignon in France. Following graduation, Dr. Watrelot moved to California and worked both at California State University, Fresno, and the University of California, Davis, to continue conducting research into polyphenol macromolecular interactions on red wine chemistry. Safe to say there's not many people know more about polyphenols in red wines than Dr. Watrelot. At Iowa State University, she is currently conducting research and developing extension programs on understanding viticultural and winemaking practices that could maximize phenolic extraction and improve overall wine quality. She had developed extension programs such as webinars, workshops, field days, and articles to answer the growing wine industry in Iowa and the greater Midwest. She is currently serving as the chair-elect for the American Society of Enology and Viticulture, Eastern Section, and as the vice president for the group Polyphenols. Aude, it's a pleasure to have you give a little presentation. The floor is yours.
Thank you, Drew. I hope you can see my screen in full screen.
Yes, it looks good, Aude.
All right, thank you. All right, so now that we talk a little bit about pomace and what to do with the water, the wastewater, so I just wanted to provide you some insight about what can be done with the pomace that is commonly used either as a compost or to create new products, but sometimes, and I would say probably most of the time, it's just put in the landfill. Where you will see it can be really used for something else, and that can be a value-added product. So pomace overall, you know that's coming from the pressing step in white winemaking and red winemaking. So in pomace, usually when you press, that's corresponding to about 20% of the mass of the processed grapes initially. And so in about 1.10 US ton, I don't know exactly how it is in European ton, but in 1.10 US tons of pomace, you have a lot of skins, a lot of stems, and a lot of seeds. And so you can imagine that it's pretty beneficial for all the compounds that are coming from the skins, the seeds, and the stems. But just more numbers. So if you consider the volume of wine that is processed every year, in the US, it's about 700 plus million of gallons of wine every year. But for about 6 liters of wine, it's providing about 1 kilogram of pomace. So if you do the math, you can see how much it's wasted every year of pomace. And so what is part of the pomace? So as I mentioned, there is skins, there is stems, there is seeds. All of those parts are pretty rich in phenolic compounds. And so I like that topic. But that's also rich in fibers. And so cellulose, pectic substance. And so fibers can be used for a lot of different process or a lot of different products. But also phenolic compounds, because that's known to be antioxidant, having antimicrobial properties. That's the way to reuse pomace could be beneficial to bring some of the phenolic compounds in the new product. And I know that in different places, they started to reuse the pomace either to add into a chocolate. So there is a company in California who make a chocolate with Chardonnay pomace. You can also use the pomace for cosmetics. So some of the lipsticks can be made out of seed extract. So that's another way of using pomace, but also you can use pomace to make piquette. And so piquette, probably you've heard about that term, maybe not, I don't know. So piquette, that's also known as aquarello, aquapazza. It depends, Laura. So it really depends on where you are located in the world, because all those terms are based on the location. So piquette, I think that's a French term. And if you know what it means in French, you won't be really willing to create that product, because piquette tends to be described as a bad wine, more like as vinegar wine, or vinegary wine. And it has that name because the production of piquette started in the Romance area, so a long time ago. And that was basically using the pomace, soaking it in water, and having a new fermentation happening to create that product. And so you can imagine that if you just use the pomace, you add water, and you don't do any specific treatment, you may have the development of bacteria that will lead to vinegar, acetic acid formation. That's why the name piquette is piquette. But the good thing about that product is it's leading to a product that is really low in alcohol content. So you will be able to have a piquette with between 4% to 9%. So it's always below 10% a piquette. And so I just wanted to provide you some examples about piquette that are produced in the US. And I'm not showing anything about France, because in France, that's illegal to sell piquette. But in the US, it's legal. And so there are a lot of different products or different piquette that are already produced, especially in California, Oregon State. And so that can be made from pomace of white grapes, red grapes, a lot of different techniques can be used. And so that's something that we tried to make with Ken Foulker last year, working on pomace from one red grape cultivar, which is Petite Pearl. So that's a hybrid. We started, 2022 Petite Pearl, and we tried to evaluate the impact of different pomace to water ratio on the quality of the piquette. So we used 200 pounds of pomace versus 300 pounds of pomace soaked in water, 100 gallons of water, for a few days, 2 days. And after soaking, those two pomaces were pressed at the same time than Petite Pearl wine was pressed. And so it was pressed with some Petite Pearl juice. On these results, on this juice, sugar was added just to make sure we started with a little bit higher bricks than the bricks that was provided from the pomace initially. So the target was about 12 bricks, and then fermentation happened for about a week. And after a week, it was directly bottled. So it was bottled into a crown cap bottles just to make sure the pressure the bottle will resist the pressure. And it was bottled at 2 different bricks. And so those 2 different bricks were a little bit too high, because the more bricks you have at bottling, the more fermentation you can have in the bottles. And so we had some challenges to open those bottles without having an explosion of piquette everywhere. And also, on the other side, we tried to make another type of piquette using same cultivar, so Petite Pearl cultivar, but we tried different yeast strains. And so the pomace was collected after red winemaking, and we didn't have time at that time just to process and to make piquette, so we froze everything before defrosting the pomace and adding some water. So we did add water, we did add citric acid, we did add some potassium metabisulfite just to protect the juice. And everything was soaked for about 2 days. We then pressed, and on this juice, we did add sugar to have a target of about 12 bricks before starting fermentation. So it wasn't exactly the same way as making I would say a real piquette, because usually if you want to make a real piquette, you just have the pomace, you add water, and then you start fermentation. But in our situation, we press and then we started fermentation on the liquid. So we tried 3 different yeasts, and then we did bottle about 1 week after, at the end of fermentation. The fermentation was not complete because we still wanted to have some sugar to have fermentation and carbonation in the bottle. And then, so we tried to evaluate how was the chemistry. And that's always interesting to see what was those different parameters. And then we also compared with sensory evaluation. But just starting on the chemistry side, so the pH you can see was pretty, I would say, low for the Petit Pearl we made with 3 different yeast strains. So PP1, PP2, PP3 were 3 different yeast. PPB1 and PPB2 were a little bit higher in the pH. And that's how it was. It wasn't exactly on the same pomace. So you can see the ethanol concentration was pretty low, even lower than what I mentioned about the range being between 4 to 9%. We were, below that. We also checked the volatile acidity, or the amount of acetic acid we had. We didn't have too much acetic acid from a chemistry standpoint, and it wasn't perceived neither from a sensory standpoint. Looking at the color, so those parameters, so you can see that depending on the yeast that was used, or depending on the pomace that was used, the hue was much higher when we used the Petit Pearl that was processed with Petit Pearl juice. And that's probably because the hue was higher, meaning that it was a little bit less pink, a little bit less red compared to the others, and the intensity was about the same. So no real changes or no real differences between all those conditions for color intensity. And so, as I mentioned, we try to see how the consumers will like or how consumers will accept those different piquettes. So we did provide those piquettes without saying that it was a product made from pomace, because we didn't want to have them being biased and being aware that it was from a waste. And so we just provide them those piquettes, and we ask questions about what do you prefer. On a scale, they had to say how much do they appreciate the color, how much do they appreciate the smell, how much do they appreciate the taste. And so the highest number, the more appreciative the consumer was, the lowest, the less appreciative it was. So you can probably see that it was all close to each other, but still PPB1 and PPB2 were different than PP, so just the Petit Pearl that was made from different yeast strains. And so overall, so the color, the appearance, and the smell were statistically different between all the samples. And so looking at just the color, you can see that color and appearance for those 2 different ratio of pomace to water, it was less appreciated by consumers than the other Petit Pearl. And so then we ask, how much would you pay if you were going to buy that piquette? How much would you pay? Just to have an idea of how much a piquette could be sold. And so overall, most of those piquettes were, so people always want to pay less for a product. But it was still interesting just to see the change of how much they would be willing to pay for the different piquette. And so if you remember what I said about the color and appearance, the first two Petite Pearl, so Petite Pearl with the different ratio of pomace to water, were with the color that was less pink and less red. And so I think that's how we can see that consumers were willing to pay less than $10 for those two. But for the other piquette, they would be willing to pay between 20 to 25, or even sometimes more than 25. So it was really just interesting just to see what was the characteristics of those piquette and how it was appreciated by consumers. And so some of them, so one of the ratio that we used was really not appealing. The color was pretty gray, brownish. So that's what was mentioned. But also one comment about the smell is that those two piquettes were pretty strong in rotten egg smell, so H2S. And that's probably because the addition of nutrients was a little bit later in the process. And so when we make the piquette, the yeast were lacking probably nutrients. That's how they developed H2S, and that's how it was translated into those two piquettes. So just to conclude on what we had, so there are a lot of different ways to make piquette, but I think that's a good way to reuse a common waste that's pretty quick to produce. It's low in alcohol. It has those sparkling effervescence in the piquette. Petite Pearl is, I think, a great grape cultivar because it's really fruity, and even in the pomace, the pomace is still very fruity. Management of nutrient is very important if you want to make a piquette, because if you forget to add some ferment K or DAP, you might have some H2S that is going to be formed. But once again, I think that's a good product that can be a good drink for summer. So that's just another option if you are interested to reuse your common waste. So if you have any questions, please type them into the chat box.
All right. Thank you, Aude, for that interesting presentation. I don't think many people have ever heard of piquette. I'm thinking about next season's harvest. I think I will do some experimental piquette making. What a wonderful way to get some more value out of what would normally be a waste product. As a reminder to all participants, please type any questions you have in the chat box, and as a panel, we will discuss them and answer them. So we're now being joined in the panel discussion by Scott Ellenbecker from Round Lake Winery, Minnesota, Jonita Boyer from Tassel Ridge Winery in Iowa, and Kent Foulker from Cedar Ridge Distillery in Iowa. Aude, do we have any questions posted in the chat box yet?
Yeah, so we have Dorothy who is asking if the original Petite Pearl fermentation inoculated with malolactic bacteria. And I would say so Kent was the one helping for this project for the pomace to water ratio. So Kent, you're saying that no, it wasn't with...
No, typically you don't want to do malolactic fermentation on sparkling wines in general. So we decided on that test not to do malolactic fermentation. You know, thinking about it being a bright, refreshing, lightly sparkling kind of beverage, we didn't necessarily. That wasn't our goal to have more of a creamier texture, softer texture. We wanted that burst of pop of flavor.
But I think she was asking about the juice that was obtained at pressing.
Oh, sure. And that one, no, we did not have, we did not co-knock malolactic bacteria in the original Petit Pearl. That came later because we knew we were going to make piquette out of it.
And so that's for the Petit Pearl with the pomace to water ratio. But for the Petit Pearl we tried with the different yeast strains, it was after malolactic fermentation. So yes, it's the difference between those two piquettes as well.
Yeah, and just one other thing too about the when we were talking about pressing the pomace after we let it soak, we did leave some Petit Pearl hanging on the vines that year. We were able to do that. So we added with that press about 50 pounds of whole cluster Petit Pearl, and then press it all together just for a little bit of added nutrients for fermentation, which we found out later on was still not enough.
Thank you, Ken.
Yeah.
Does anybody here have a Aude, you mentioned that you had some problems with the higher bricks at bottling. Piquette got built up too much pressure. Do you have a general range of bricks at bottling that you think would be appropriate?
Ken, do you want to try?
Yeah. So on bin 1, we had it at 2.6 bricks or a 1.010 specific gravity, depending on what you're looking for. Our bin number 2, which I think had the 300 pounds of pomace per 100 gallons of water, that went all the way down to 1.5 bricks or 1.006 specific gravity. Both of those were rather high. I would, if you can get below a brick residual on that during fermentation, I think that would be a safer bet, because yeah, even we did a couple cases of each, but ultimately, so that we had a usable product, we ended up wieing the 2 tanks together and bottled them as a blend. So I would say it was probably closer to 2 bricks when we went to bottling, and they were all a fountain of fun. So I would say try to get it closer to a brick at least when you do decide to bottle. And when we were talking about H2S earlier in the presentation, just kind of think, you know, on typical wines, you may want to go the copper route, but because this is being captured in a bottle during fermentation, you cannot use copper. That will go into the bottle and into the consumer. So that was not an option for us. So just something to keep in mind.
So so monitor your piquette fermentations often with your nose, and add fermentation nutrient as needed. Would you think off the top of your head that you wouldn't even wait until you could smell
No.
the fermentation struggling? You just go right ahead and add what I would call a prophylactic dose?
Absolutely.
Yeah. I've noticed the same thing in apple ciders. I've been doing some apple cider research, and apple juice seems to be low in nitrogen, and I've talked to other cider makers, commercial cider makers, and most of them do go ahead and add some nutrient, maybe just a day or 2 after they've added the yeast, just to avoid any H2S occurring. There's a Randall Weaver mentions that in his experience, he's called a piquette a second run wine, which is as good as any term, and that he's actually won a gold medal at the Iowa State Fair with a second run wine. He mentions that he didn't know there was a name for it. Yeah, piquette in the French. Aude, can you remind me? I think piquette sort of traditionally in history, that piquette was made as sort of something for vineyard workers and winery workers to consume at lunch or at dinner with their meals. And I think at one point there was even a law against paying workers with piquette. Is that true?
Yeah, so I think it started, so as I mentioned, it started a long time ago, just because the pomace was sitting here with water, and that's how it became piquette. But at some point, it turned out that it was more a drink, easy drink for vineyard, workers, vineyard and winery workers. because it was just made in a quick amount of time. So in a week, you had something. You had a product that was sparkling, low alcohol, so nobody was really drunk with this piquette. And
basically,
yeah, so I mentioned it is forbidden to sell piquette in France, and I think in other countries in Europe. And that's probably why you were not allowed to pay your workers neither with piquette. So that was just a way to use that common waste.
And cheap and fast and easy to produce. Yeah, it has some appeal.
Mm-hmm.
We have a comment here from I think they have a code name, or maybe it's their last name, Tizok, who mentions that 18 grams per liter of remaining sugar is a nice number for pressure production. That's about 1.8 bricks. I think from your experiment that might be a little bit high. And then he has another comment that says that 1.8 gram per liter of remaining sugar will produce about 4.5 bar of pressure, which is about most traditional method champagne, I think, is about 6 bar, which equates to about 90 pounds per square inch. So maybe 4.5 bar is still a little bit high. I don't know. And then there's a comment from Scott. Scott, is that from you, Scott Ellenbecker?
So how much volume did each bean produce for bottling? I think so for our piquette that we did at ISU, we were working in really small batches. We were working with 1 gallon of water. And so we had at least, I would say, 4 to 5 bottles max. But then for Kent, how many bottles did you have for the 100 gallons?
Well, we didn't end up using the whole batch, but we finished right around 40 cases of piquette, and we probably could have done another 40. But it was, I mean, we were filling each bottle one by one, just me and my assistant at that time, and it was painful, and we were watching the bricks drop as we were working all night long, and then at that point, I was thinking of consistency of product. The way we were filling it, that beginning bottle and end bottle, it was going to be a different product. So I called it so that I had at least 40 cases of uniform piquette. But if we had a different facility, and again, this was a very, very, very new facility that was very small. If it was just what I would consider, like if it was like Cedar Ridge, we could have done it in an hour. But in this case here, it was very, very, very slow and manual, and we ended up with 40 cases, a safe 40 cases. Yeah.
And did you use those just for experimental evaluation, or did you actually sell those commercially?
All the above. Yeah, we used it as an ingredient. We marinated products with it. We made them into cocktails. We sold it, just as is. A wine in general is more than just a glass of wine. It can be many things. So we used it as many things throughout the homestead there. Yeah.
I like that philosophy very much.
Yeah.
And your customers seem to enjoy it?
They loved it. They loved it. And one of the weddings, when we just kind of, showed them around, as a fresh engagement looking for a wedding venue, we greeted them at the door with a glass of piquette and a nice big coupe. And they thought that was just the greatest thing. And then that's what they wanted for their wedding. So we did the toast with a piquette, and they loved it.
Good. Thank you for all those explanations. Yeah. So going back on wastewater, how do you manage your water use in your wineries? Jonita, Scott, and?
I have a story if you want it. All right. So in the last, what did I start? I started there in March of 15 at Cedar Ridge. Winery, distillery, restaurant, and we were on one septic back in 15. And then we grew fast all the way until today. So we added another septic system. We were on the well, we were in septic. So we had a septic for the restaurant and, front of house. And then we had a production septic added later on. And still we were having a truck pick up septic overflow almost. Basically, they were pumping our tanks almost on the daily and taking it to wastewater management, which is very expensive. So we got a bioswell. So for going surface. So we would have our septic, and then any overflow would go into a bioswell surface application where it would go into a small pond at the top of the hill. And Cedar Ridge is topographically, it has a lot of steep hills. So we had about 5 ponds going down to our large pond. So that overflow would go to the top pond and then fill up and then go over like a waterfall, releasing, getting oxygen added into the product, to reduce the BODs. We had a lot of nitrogen consuming plants planted all along the entire thing to absorb more of those elements before it made it all the way down to the pond, where it was a larger body of water and any residual would be consumed there through other sources. But we grew and continued to grow, and those BODs got higher and higher. We ended up killing everything in our pond, which is connected to our neighbor's pond, and we killed all his fish too. So after tens of thousands of dollars in fines and restocking all the fish over time, we are now with an evaporator. So between the winery and distillery, it goes into these holding tanks, and it's just like a stock pot. It's just constantly boiling and evaporating until we get a thicker mass. And we're currently looking at finding ways to, there's like this algae system where we can create these into pellets and use them as fertilizer, but we don't have that yet. So we're still pumping that to wastewater. But we're running into a new now issue where the pH of this evaporation from the stillage and from the winery is so acidic that it's starting to eat away at the metal materials within the evaporator. So we just spent $20,000 on a new piece. That's going to be good probably for another couple of years, and we're going to have to do it all over again until we find a new solution. So we're currently still working on trying to find the best and most resourceful way to mitigate our water, dispersion. So that's kind of where we're going with that. And we're still, like I said, the trucks are still pumping. Luckily, the company that does pump our septic, they take all of our spent grain from the distillery as like a kind of a trade-off of dollar amount. And also, after we get done using our pomace, instead of making piquette, we make grappa. So it's very similar as piquette, but we then distill it into a product. We go through and it comes out around 180 proof in the end of a grape spirit. And then we can use that for a lot of purposes, whether it's for fortifying wines or selling it as grappa. But there's lots of ways that we can reuse that. But those skins, then after we make grappa, so the second use of the skins, then it does go to the cattle, and the cows, they just gobble that stuff up. They absolutely love it. So we will send that to that farm. And again, that trade-off kind of pays for the cost of pumping a lot of that product to wastewater management. So that's kind of where we're at with our wastewater right now. We're still, it's a ever growing, as we continue to grow, it's an ever growing system that we're just constantly upgrading and upgrading.
Do you have the same system, Scott and Jonita, for wastewater?
Last year, in 2020, we had to put in a new system. As we added on to our restaurant and we increased our production facility, it was required that we went to a much bigger system, looking at the number of seats we had. That's how Minnesota judges it. Every seat is worth 30 gallons of water. We have over 200 seats, and that was going to put us over 10,000 gallons. So that was a very expensive system. extremely expensive, like $500,000. And then, so I got a engineer involved, and we looked at all of our water consumption. And I can tell you on a daily basis, just as we were listening earlier, I looked at it. My average for the month so far is 1,144 gallons a day. But our system was designed, because we're allowed to because of our usage, at 5,000 gallons a day. Last weekend, we had a full restaurant, music Friday, Saturday, Sunday. Saturday, we had our wine club pickup with 200 people. It was a huge party, and we still only used 1,800 gallons. So as the state says, you have to go by all these, and we have multiple facilities. So there's 200 in this restaurant and 200 in another building. Anything that is going through the production facility goes into that same system, but it has a 10,000 gallon tank buffer at the beginning. So it will basically process down over multiple days. So when we're dead around here, Monday, Tuesday, Wednesday, Thursday, like most wineries, we have a whole bunch of water that will build back up for the weekend, and then it's processed down, and it goes through a bacteria process. So we're very, very careful about what does go down in the septic system. You can't use any harsh chemicals. You can't use quat. Some of those things that are standard in restaurants can't be used in our septic system. And the system did cost $250,000. So it was still expensive, but it has given us, we can double in size and still not have a problem with the system. We do in the fall. Logan is sitting next to me. He's hiding here he does put too much stuff down the drain, and he should use a broom more often and get rid of some of that out on a field somewhere. But it's so easy to push it down the drain.
We do have another tank right off of the production building. So we're starting now where we're pumping it before and after harvest. So the extra solids get caught in that tank before it gets the big tank in front of the main system. Mm-hmm. And we have noticed that helping out a little bit. It catches more of the skins that get down and the extra settlement from the fermentation. And then during that time, there's also so much nutrients going through that our septic does smell a little bit more because of the extra bio going in there, and the yeast or the bacteria just going crazy.
Sugars are huge that time when you're cleaning the floor and everything's sticky going down the drain. So it will crash the system. Creates foam, creates lots of stink and smell. So the engineer who designed the system, we went back to him and he said, just pump it out before, and then during the process, just do a land application. And he says that's going to be fine. So he's the one designed it, so he's the one telling us what to do. And then we don't have any human waste in there. It's everything that comes from the floor drains and the tank. So you all know what it is. It's what it is. So that's
right.
System.
Yeah, thanks for sharing. Jonita, do you want to explain what you do?
Sure. We have 2 lagoon systems. So our human waste is separate system than the cellar. And then we go through 3 holding tanks to get to the lagoons. And we do get our holding tanks pumped out probably twice a year. So probably right before harvest, and then probably after harvest. Like, I think it's in 6 months. I'm really not in charge of that because I don't really know, but I know I put stuff down the drains, but I don't pump it up. So, but we used to have to test our lagoons monthly, but now we just have to test them before we like spread it in on the yard or whatever, before we get rid of anything. And that's like, I guess it's the BOD. And then we've never had to really dump too much chemical down it, so that's good. This year, our lagoons are low because we had no water. So we didn't really have to irrigate too much. So they're kind of low right now. So hopefully we have a good winter so we can fill them back up. But yeah, and we do use like a must pile or we spread that on our bean field or cornfield after harvest. So, but that's it.
And now you're considering saving some of that and making some piquette, I assume.
I am not convinced. I think Kit would be a great candidate for that. I mean, I would try a bottle, but I am not 100% on board yet. Because the fountain of fun does not sound like a fountain of fun to me.
That's what we try for you, Jonita.
Yeah, you try it and get back to me.
I surveyed some of our regional winemakers about piquette because we have another project going on that's even wackier than what you have all, because we're using acid whey from Greek yogurt production as our liquid because, you know, why not? Two-way streams, right? The story writes itself. So, so I surveyed the winemakers that I knew, and I said, you know, how do you feel about piquette? You know, I'm interested, I'm uninterested, and I'm actively trying to sabotage anybody who's getting me to make this. And I got a surprisingly large answer in the C department, but more and more people are making it. It is happening more and more. We'll see where it goes. Yeah.
Aude, I notice another question from Dorothy O'Brien at Wide River Winery in Iowa, asking, does anyone use lees in compost? I'm assuming she means post-primary fermentation lees, in other words, dead yeast cells. Yes, and she agrees that is in fact what she's asking. So tank bottoms and barrel bottoms, is anybody using that in compost?
We're not necessarily in compost. We do, since we do the grappa, style that we're always looking for that to distill, we will use the lees and blend that in with that fermentation. Same thing with, let's say we do whites and we do a 48-hour cold soak after we press. So we'll rack that juice off of all the must that's on the bottom, and those solids that are at the bottom. We'll take
the gross juice lees.
Absolutely, lots of sugar in there. So we will pump that in with the skins as well, and do fermentation that way. But as into our actual compost, no, we don't put the lees in there.
All right, Chris, real quick.
Comment on that too. When I was going through the process of testing our what we were putting down the system for the state and for our engineers, I did send samples of that lovely heavy gunk down on the bottom of the tank, and it came back saying we recommend you use this as a fertilizer because it's so high in good quality nitrogen that we could use it and not have to use fertilizer. But it's hard to work with, right? It's nasty.
I'm really curious. I want to ask a question about lees filtration. Kent and or Scott and or Jonita, because all three of you are sort of that medium size winery, not large but not small. Do any of you three have a DE lees filter? No, and no. Okay. I worked at a winery in California where we processed between 600 and 800 tons a year, and we had a large DE lees filter. We would put all the white juice settling, as well as the post-fermentation red wine tank bottoms. We had a dedicated guy who would operate that lees filter, and I remember once he was complaining that he didn't really feel like he was part of the cellar team because he was constantly just running this lees filter. And I was looking, he had these 120-gallon bins of stuff coming to him that he would put through, and he would recapture 80-90% of either the white wine juice or red wine out of that gunk at the bottom. And I sat there really quickly and did the math. I say, okay, 120 gallons, that's about 45 cases, and at $20 a bottle, wow, each one of these bins is about $14,000, and you've done 8 today. Gee, you just saved the company about $100,000. Well, all of a sudden he had a better appreciation for running that damn filter. Again, this was a much larger winery. I never want to have to operate a DE lees filter again because it is a big mess. But that is another option for people to consider. Chris, do you see a lot of lees filters there in larger wineries in New York, or not so much?
There are some. DE, of course, has its own environmental considerations, and we're trying to
Good
get people
point.
to move away from using DE because it's hazardous. But I take your point about the reclaiming. High solids cross flow would be what we'd hope that people maybe look into now, or things like that, or some kind of alternative. And there are options out there. But yeah, anytime you can do that, it is as you mentioned, a scale issue, right? And so it has to be worth your while to get the scale, and that's the issue with a lot of these things. The grappa is a great choice. Piquette is a great choice. There are people who are doing things with like flours and all these, FLOUR flour, right? Where you can make flour from, we can get, because as Aude knows, there's, all these anthocyanins, polyphenols, in these compounds and everything like that. And once again, it becomes a matter of scale, right? What's the size that becomes commercially viable to use these products? But yeah, ways that you can lower your flotation, I think, is people use flotation, that often cuts down on your lees. Other ways you can do that, reduce the size of the system.
A couple years ago, you just made me think of alternate uses. A grad student here at the University of Minnesota asked for a few pounds of red pomace. He and his team had an idea of creating, in Minnesota, we salt the roads in the winter to clear the ice. And they were working on a project to turn grape skins into a more environmentally friendly way to de-ice the roadways. That was a couple years ago. I haven't heard any results yet, but I thought that was a very creative idea.
I have a couple other ideas for pomace that we actually use every year. We partner with maybe 4 or 5 different breweries. They love the grape skins. They make sour beers, wild ferments, saisons. They do all different kinds of fun things with grape skins. So breweries will come out with 5-gallon buckets and they are scooping. They love it. So if you can collaborate with a local brewery, maybe even a coffee roaster. Sometimes, we do a lot of coffee aged in barrels. You got some wine barrels laying around that you maybe want to retire. Coffee roasters love barrel aged products as well. But yeah, use that pomace with, collaborations with breweries. That's a great way for marketing. You might get a couple beers out of it, and like we all know, it takes a lot of good beer to make good wine. Otherwise, another thing too, like Scott, you were talking, you have restaurants, right? We take some of that pomace, and we will soak some and get about a liter of that concentrate, that liquid. We'll take it off the skins once we have that colored liquid there, and we will reduce that down to about a half a cup. And then you take a tablespoon and you pour that over top of large grain sea salt, and it turns that sea salt purple, and you can use that for finishing salt, and people at restaurants just gobble that stuff up. You're not going to taste grapes on salt, but it's pretty, and people think that's really cool added value by just using skins.
That's brilliant, Ken. Never heard of that one. I have been working with a local brewery here who has taken some of my white wine skins, as you say, it made some sour beers, and they were delicious. And I believe the quote is, "It takes a lot of good beer to make great wine." All right, Aude, I see we're down to the last minute or so. Do you want to take a minute, Aude, and remind our audience about the final webinar for this year, next month?
Yeah, thanks very much. I hope we would have more time to keep discussing about that broad topic, but hopefully next time we can keep the discussion. So yeah, thanks very much for attending and participating to the webinar today. We hope it was helpful and brought some new knowledge to you. And please send us an email if you have any questions that we didn't have time to answer. So before closing the webinar, so keep in mind the last and the next webinar is about wine filtration on December 12th. And so we would really appreciate if you can take 2 to 5 minutes to complete the survey. That is either by scanning the QR code that you have on the screen, or you will receive an email and just answer to complete the survey by clicking on the link. And so that's the end of the day. Thank you so much, everyone. Thanks, Sara, for presenting. Thanks, Chris. Thanks, Scott, Jonita, Kent. Great discussion. Thank you, everyone.
Thanks everyone.
Thank you, Aude. All
Yeah,
right.
thanks,
We'll see you all next month.
All right. Have a good day.
Bye.
Bye-bye.
Bye.